graphing. All right, graphing quadratic functions. So the graph of a parent quadratic function is y equals x squared. X squared is the most basic quadratic, right? That's kind of like how you can think about it for the parent function, all right? It's a U-shaped graph. Do you know what it's called? A U-shaped graph. It starts with a P. Yeah, parabola. Called a parabola. And they give you the parent graph right there next to it, okay? The parent function. All right, so what is the vertex for y equals x squared?
Y.
0, 0, right? That is the vertex right there. What is the axis of symmetry?
X to the second.
X equals 0. Remember, axis. X equals, and then it's just the x number from your vertex, right? It's where you could basically divide this parabola in half, right? It's where it shows where it's symmetrical. All right, so there are three forms of quadratic functions. There are three different ways to write this, okay? The standard form looks like this. Y equals ax squared plus bx plus c. Yeah? Then you have the vertex form. Y equals a times, okay, so in parentheses, right? This form helps us to get the vertex, x minus h squared, yeah, plus k. Right? We like the vertex form for talking about transformations, right? For getting our vertex, opposite h comma k, right? All right, and then intercept form. These are the x-intercepts, all right? This is y equals a times, and then your two intercepts here, so you could draw your two parentheses there, okay? X minus p times x minus q. Okay? Raise it up a little bit there.
What does P and Q stand for?
P and Q, those are your intercepts. All right? Okay, so right below that it says describe the transformation of f of x equals x squared. Okay, and then write the new function in vertex form. Okay. So looking back up at your parent function, the vertex is at 0, 0, right? And then it's what? Up 1, right 1. And then, yeah, up 1, right 1, and then what? 2, 4. So it's like here. It's like this, right? Okay. Oh no, I'm just sketching it. All right. You have your parent function graph right here. This guy. This is the one. Okay. So what are we doing? We're looking at this graph, and we're talking about the transformations. How did it move? Tell me in words, right? And then we're going to get the vertex, and we're going to write out the function. Okay. So if my parent function is over here, vertex to that vertex. What did it do?
Up to.
Okay. Is that what you're going to say? Up to 2, 3, 4, 5. Right 5. Okay. You don't need this, right? Let's erase that. Yeah? Did it flip? No, it's still U-shaped, right? All right. What is the vertex here for this graph? Okay. 2. And we need to put this in vertex form, right? Yeah? Y equals, now remember, this is always,
I thought there was an A before it.
I know, but the A, okay, so the A before it tells you if it stretches or compresses. This one didn't, right? So you have parentheses, and you have the x minus, and you have the square, right? All right. Inside with the x tells me left or right, yeah? Since it went right 5, put in the 5, right? And then up 2 means it's got to be this k, and you'll say plus 2. Good. Any questions about that? All right, let's try the next one.
It was
Give me a
flipped.
transformation, please.
It was flipped.
Okay, so it reflects or it flips. And what else? It was at 0, 0, the parent function, and now it's up here. What did it do? Up 5 and right 3. Good job. What is this vertex? 3, 5. So now let's rewrite this. Well, let's write this function. Y equals, what do I need? Negative. And then set up your x minus, right? With a square.
3.
Since it went right, oh my gosh, I didn't even write that down. Right, what? 3? Okay, so then 3. And then plus 5. Yeah? If that was left 3, then I would have to put a minus 3, right? But then what's minus minus?
Plus.
The plus. Okay, good. All right. Okay, so graphing quadratics in vertex form and standard form. All right, take a look at this. Here's the thing. When you guys graph, right, we're going to practice making a table of values by plugging in, all right, because I'm going to show you how to do that. But, you know, the first thing you always want to do is get your vertex if you can. If it's in vertex form, then that's great, right? Create your table, and then, of course, we're going to plug in without the calculator, but use your calculator to find the points if you're unsure or if you want to check, okay? And then plot your points and draw your parabola. All right, so number 1, which form is this in? Vertex. Okay. Oh, and then you know what? You know what we should do? Let's do this. Let's add a little something extra for our class. Go back to the first page. Oh my goodness, so exciting. You ready for this? Yes. All right, so I promised you that we were going to try filling in and making our table of values by just plugging in values, right, to find our vertex. Standard form. Let's write down how we can find the vertex for each of these forms, okay? The vertex is x comma y. Do you agree? All right. So how do we find the x number if it's in standard form without the calculator? Well, it's in A, B, C, right? Lined up there. Negative b over 2a gives you the x number for your vertex. Okay? Once you find that x, plug it into your equation, and then you can get your y. Plug in x to get y. Does that make sense? All right, if it doesn't, you'll see it. I'll show you. Okay? But you can always put this right into the calculator and get your vertex as well. All right? So that's for standard. For vertex form, well, vertex form, I love it because it's there. You know the number right here, your h?
That's y.
Yep, you want the h number, but remember it's a negative. There's a minus h, right? So when you switch it back to your vertex, you know, I think of it as like the opposite h number. So if it says x minus 3, I think plus 3. Okay?
Wait, doesn't the k go in front? Oh.
So if it says x minus 3, then it would be positive 3. Okay? And then if it says x plus 2, then it would be negative 2. Does that make sense? All right. And then your y value comes from this k, whatever your k is. If it's plus 4, then it's just 4. Yeah? So the vertex form I like because we can actually get the vertex right from that equation. Now, intercept form is a little bit different. Okay? Intercept form, in order to find the vertex, all right, so you see this P and that Q? They have a minus in front of them too, right? So I kind of think opposite P plus opposite Q divided by 2 gives you your x, okay? What I mean by opposite P and opposite Q is that if it said x minus 3, then what P number are you using? 3. And if it says x plus 2, then what Q number are you using? Negative 2. Okay? All right, it's because there's a negative in front of, there's a minus sign in front of it. So when you're bringing it out of the intercept form, just think opposite of that number, okay? Divided by 2, that gives you your x value. Then just plug it in. That gives you your y. So for standard and intercept form, we're finding the x, plugging it in to get our y. Vertex form is the only one where we can just get x and y straight. Does that make sense? Yeah. Plus opposite q. You're getting those numbers from inside the parentheses with your x. All right? Okay. So, let's go back to number 1.
Negative 4q.
Yeah, what form is this in? Standard, vertex, or intercept?
Vertex.
Vertex. So I can go and get my vertex right away. Opposite h, comma, k. Right here is x plus 4. So what is the x number? Negative 4. And what's my k number?
2.
2. So there you go. My vertex is negative 4, 2. Yeah? So if I know my vertex, what's my axis of symmetry? X equals what? Negative 4. Good. All right, so tell me about the transformations here.
To the right 4 up 2.
So, okay, this x plus 4, how does that move?
Oh, left 4.
Left 4. There's a negative in front. What did that do? Flips or it reflects, right? And then this plus 2 on the outside.
Up 2.
Up 2. Good. All right, so negative 4, 2, right? I'm going to put that in my table of values. The vertex we like to put right in the middle, right? So we can get 2 values above, 2 values below. So if you wanted to do this without the calculator, just a couple numbers here. -3, -2, -5, -6, right? A table of values is just something for you to make, to kind of help you graph. You can choose any numbers you want to. The only time that your choose any numbers you want to for the x doesn't work is if you have a fraction. Then you might end up with some weird numbers. That's okay, right? So if I wanted to find this by hand, I would plug in -3 for my x and get my y, right? So then -3, plug that in, is what? 4, 1, -1, plus 2, 1. Oh no. Did I do it right? -4, 2, -3, 1. Did I do it right? And then -5.
Isn't that -1 then instead of just 1?
-5 and 1.
Because you have -3 and 1. Wouldn't that just be -1?
No, because order of operations, you have -3 plus 4 squared plus 2. That's 1 squared with the negative in the front, right? That's 1. -1 plus 2 is 1.
But how does that go? Oh, never mind.
But here's the thing, right? You guys have calculators, okay? So unless we say don't use a calculator, or you're in pre-calc next year and they said don't use a calculator, you can't. Go to y equals. We're going to put this equation in. -x plus 4 squared, and then plus 2. Yeah?
Second graph.
So you want to look at the graph and make sure it looks like the transformations that you said. It reflects left 4 up to. Did I not put plus 4? I did. Okay. My graph looks so weird. Oh yeah, no, it did. Okay. Sorry. All right. So then if I go to second graph, it takes me to my table, right? And we said that the vertex is there at what? -4, 2? So just give me 2 points below, 2 points above. There you go. Your calculator did it for you. Yeah? And if you want to go one more because you have all this room, sure. Feel free to. Okay? And just make sure you draw it like a parabola and not like an absolute value. Just don't make it a sharp V to round it out a little bit. Okay? So now look at this guy. Do we have a max or a min? Max. Because right here goes up to the top of the hill, right? So your maximum is what point?
-4, 2.
Yeah, -4, 2. Isn't it the same as your vertex?
Mm-hmm.
Do we have a minimum? No. Okay. Now, let's talk about, we'll come back to the intercepts. Can we talk about the domain here?
Mm-hmm.
Yeah. So the domain is looking at the graph from the left to the right. Yes? So if you look at this graph, guys, this arrow on the left, it keeps going to the left forever and ever and ever. Where are we going? To negative infinity. So from negative infinity all the way to, I have an arrow on the right. Arrow on the right forever and ever and ever. Where's it going? To infinity. Good. the domain is all real numbers, negative infinity all the way to infinity. If you think about a parabola and the way a parabola is shaped, right? Are you always going to have an arrow on the left and an arrow on the right?
Yes.
Yeah. So then what is your domain always going to be?
All real numbers.
Negative
All real numbers. Negative infinity to infinity, right? So let's look at the range. So the range always looks at the y values, right? Basically from the bottom to the top, where is my graph, right? So look at this graph. The arrows are going down. So where are they going?
Negative infinity.
Negative infinity. So we're coming all the way from negative infinity, and then this graph stops where?
2.
2. All right. So all the way from negative infinity to 2 with a bracket, because that's a closed circle. Yes? All right. Okay, so let's talk about the increasing and decreasing intervals. All right? So increasing and decreasing, we look at the x numbers, right? The x values. Basically, you have to draw the easiest way. Draw a vertical line where this graph changes direction at your axis of symmetry, right?
Good job.
Nope.
Take
Okay.
two.
So
Shut up.
I'm going to draw a line right through where it changes direction, which is my axis of symmetry, right?
Mm-hmm.
What x number does that go through?
Negative 4.
Uh-huh. You have an arrow on the left. Where's that going?
Negative infinity.
Negative infinity. And you have an arrow on the right. Where's that going?
Infinity. Negative
Good.
infinity.
So here, you're going to tell me, yeah. Uh-huh. Domain is left to right. So here, you're going to tell me what the graph is doing from the left to the right. So from here to there, what's this doing? It's increasing. What's it doing from here? Good. Decreasing. Yeah? Gotta look at this graph from the left to the right, okay? So your intervals are, you've already written them. Now you just have to tell me which one's increasing and which one's decreasing. So increasing is from negative infinity to negative 4. And remember, increasing, decreasing, and constant, you always use parentheses, okay? And then it's decreasing from negative 4 to infinity. Okay? So this last row here is talking about your end behaviors, right? So end behaviors are kind of like, I mean, as x approaches negative infinity, you can kind of think of them as like the arms of the graph, right? You have arrows, so you're going to have these end behaviors. As your x values get smaller, what are your y values doing? Is what it's saying, right? So that's why we can look at the left arrow, and you guys can tell me, is it going down to negative infinity? Is it going up to positive infinity? Or is it going straight and getting stuck at a number? What is this one doing?
Going down.
It's going down. Down to where?
Negative.
Huh. Okay? And then as x approaches infinity, so, I mean, if you get your left and right confused, you can think, okay, if I'm walking on the x-axis and I want to go towards infinity, which way do you have to go? You have to go to the right, right? So then this one, what is the right arm doing?
Infinity.
Yeah, going down to negative infinity. Okay? All right, so I saved the y-intercept and the x-intercept, right? Okay, so I'm going to show you two ways here. not that one way is better than the other. I want you to see both ways. So, in order to find the y-intercept, right? In order to find the y, you're finding the y number, so your x number is 0, right? Are we okay with that?
Mm-hmm.
Okay. So, in order to find that y number, you need to plug in a 0 for the x into your original equation, right? So if you plug in 0, what do you get?
2.
0 plus 4 is 4, square is 16, negative 16 plus 2 should have negative 14, right?
Mm-hmm.
Yeah?
I was thinking.
All right, but,
Wait, isn't... never mind.
yeah?
Mm-hmm.
But here's the thing. I mean, you don't have to. You don't have to do it, in your head or by hand, right? You can go to your calculator, and you should write down these steps if you like this, okay? Put your equation into y equals, go to graph, right? Hit trace, 0, enter. And then it tells you 0,
So, like,
comma, negative 14.
here's the thing. If I were to put anything on this one,
Mm-hmm.
I would get this. Get an error.
You get aired?
Okay. All right, I'll look. Oh, wait, hold on. I'll look at it. All right. So if you want to know the y-intercept on the calculator, you can hit graph, trace, 0, enter. Okay? Or if you want to check yourself, it's fine. Now the x-intercept, all right? Well, if you're looking for the x-intercept, that means that you're, and this one, make this a little bit smaller. First of all, look at your graph. We have 2 x-intercepts, right? I'm going to make my parentheses smaller here. Okay? If you're looking for the x, that means that your y is what? 0. All right. If your y is 0, that means you could plug in 0 for your y in your equation, and then just solve for the x. And that's all you're doing, okay? So 0 equals negative. All right? Look at that! Square root method. Oh my goodness. So good. Subtract the 2,
And then you'll divide by the negative.
and then divide by the negative. Yeah?
Put square.
Divide by negative 1. Then you have, yeah? I'm trying to get to this x, but it's inside the parentheses, right? You got a square root in order to get rid of the square, right? But when you guys write the square root, what do you have to put? Plus or minus. Yeah? So then you have x plus 4 equals plus or minus root 2. Yeah? Okay. But I didn't solve for x yet. I have to subtract the score. Alright? And when you add or subtract something, and there's already a plus or minus on the other side, this guy has to go in front. Alright? So x equals negative 4 plus or minus square root 2. Okay? So, the thing is, that's kind of, that is exact. But on the homework and stuff, we're okay if you guys give us decimals. Alright? So, this decimal is what? 4 plus square root of 2. Okay, so we're thinking negative 2.59, comma 0 for one of them. And then the other one would be, what, negative 4 minus root 2, right? Negative 5.41, right? Because if you're graphing this, does it help you any if I give you the radical? No, like you have to have the decimal so you can go graph it, right? Okay. I'm going to show you how to find this in the calculator too. What is this one? Negative 2.59. Oh no. 9. Negative 5.1. Sorry, I can't fit it all there. Is that okay?
Mm-hmm.
All right. So let me show you how to put this into the calculator. All right. So we put the equation into y equals, right? And then we go and graph it. Okay. On the left, I have one x-intercept. On the right, I have another one. Yes? Okay. So here's what you do. Go to second trace. All right? And then go to 0. Because it is. An x-intercept, 0, root, solution, 0. All right, so you're supposed to see a little blinker. Where is it? Because I don't see it. But you see this x equals? X equals, it says 0. That means, where's this graph at 0? Way down here, right? I'm going to click the left button until it comes up. Yeah? You guys see your little blinking bob?
Totally.
I named him Blinking Bob several years ago. Blinking Bob, why not? Right? All right. So, what you want to do is take Blinking Bob, take him right over to that x-intercept, okay? That's your starting point. Think of it this way. That's your starting point, okay? Now, your calculator's asking you left bound. All right, from there, go to the left. Hit the left button, I don't know, like 3 times. 1, 2, 3. Hit enter. Okay? Now it's asking you for the right bound. That means we're going to go back to our answer. This is what we want, right? And then from there, we're going to hit the right button like 3 times. 1, 2, 3. You know what you're doing is you're telling the calculator where to look. From the left, from here to here, scan this area to find the solution. That's what you're saying, okay? So your calculator is going to look in between this space. And it says guess. Well, hit enter again. And look, negative 5.41. Yeah? And then you do the same thing to find this one. You just go to second trace 0 again. You do left bound, right bound. Okay? All right. So, is that it? Is that it for this one? All right, good. Let's try another one then. All right. Let's try this one. Actually, you know what? Let's try this. Standard. Yeah? Because we can always go back and you can try this on your own. So, number 3, it says graph. Okay. Which form is this one in? Standard. All right. I showed you how to find the vertex, you know, by hand, or you can find the vertex using the calculator. I showed you how to do it by hand. I'm going to show you how to do it in the calculator with this one, okay? So y equals negative x squared plus 4x plus 4. All right. Go here. Go to y equals and put that in. Oh, no, negative. And then graph it.
That's
with this one, and if you're doing it by hand, do it, and then see if make sure we get the same vertex. So with this, if you want to find the vertex on the calculator, you have to determine if it's a maximum or a minimum. All right, because there isn't a look for the vertex. There's a look for the maximum or there's a look for the minimum. All right, what is this one? Maximum. So go to second trace again, and then click on maximum. All right, second trace maximum. And then what you're going to do is you're going to move Blinking Bob to that maximum that you want. That's my maximum, right? You have to tell the calculator the left boundary. Where does the left start, okay? So go to your max and then hit the left arrow, I don't know, 3, 4 times, okay? Then hit enter. And then for right bound, go back to your maximum and then hit the right arrow like 4 times. 3 or 4 times. Okay? So you see how I'm telling my calculator where to look. Yeah? From this left to that right. Look there to get the maximum. And it says guess. Hit enter. 2.0000, that's 2. Right? 1.9999992. Okay. 2, comma 8. Yeah? Any questions?
If you wait, how did I find it? Oh, if you just go to graph and you move the cursor thing around, you find it the same way.
You know what though? That doesn't work if you get a fraction or if you have a decimal. Don't just use the trace button, okay? That doesn't always work.
Okay.
All right. Did anyone try this by hand to get the vertex?
No.
No? You did? Okay. Look, I showed you how to do it. Remember, it's negative b over 2a. You know that's that first part of the quadratic formula, right? Negative b over 2a. Yeah. Comma, and then plug in. All right. Your b is what? 4? So opposite 4 is negative 4 over 2 times negative 1, negative 2, right? What's negative 4 over negative 2? 2. Okay. Right? And then take that 2, plug it in for your x's. So then what do we have? Negative 2 squared plus 4 times 2 plus 4. Is that 4? Negative 4 plus 8. 4 plus 4 is 8. Yeah. Yeah. What? Were you going to answer?
No, I was going to ask.
Uh-huh.
What would be -2?
No, because your parentheses go around the 2. So order of operations, PEMDAS, parentheses, exponent, multiplication. Yeah? So this big thing is not 4, but it's 4 times the negative 1, which is negative 4. Okay? But you could literally just put that whole thing into your calculator, too, with the parentheses and all. All right? So, I mean, you can use either one. What is the axis of symmetry? X equals 2. Oh, and look, max or min? Max. And that's the same as your what? Vertex. See? Didn't we look for the max when we went to go look for the vertex? So then what does that mean about the min? Do we have one?
No.
No. All right. Wow. Look at all this that we can fill out before we even graph it. Right? I mean, what's the y-intercept? Just 8? What? 8? Graph, trace, 0, enter, 0, comma, 4, which is right there, right? Yeah, where does it cross through the y? Right? here's something else. What did we say about the domain? Always. Right? Negative infinity to infinity. Because we have an arrow on the left that goes forever to the left. Arrow on the right that goes forever to the right. So negative infinity to infinity. All right, well then, you know what? Let's graph this. So 2, 8, my vertex should go in the middle of my table. Okay? And you guys can plug in numbers and plug it in, but it just takes up so much time, right? If I can get my table of values straight from my calculator, second graph, why not? So 2, 8 right in the middle, then I have 1, 7, 0, 4, 3, 7, and 4, 4. Right? Anyone have any questions so far? Okay. So 2, 8. 1, 7. And you know what? Just because I have to look for my x-intercepts, and instead of just crossing the x-axis anywhere all willy-nilly, why don't we just get a couple more points? You know what I mean? Like find what 5, you know, what the y value for 5 is, and find what the y value for x equals negative 1 is. Okay? I guess it's still going to be all willy-nilly there, right? It's going to go through a nice place. Yes? You know, unfortunately, it doesn't go through at a really nice place on the x-axis, right? So my x-intercepts are going to be decimals again. It's fine, right? What is my range here, you guys? From the bottom to the top.
8.
Negative infinity to 8. Good. Don't say 8 to negative infinity because we don't look at the graph from the top to the bottom. We always look at the graph from the bottom to the top. Okay? And 8 gets a bracket because that's a closed circle there. Yeah? You know, we can come back to the x-intercept, do that last. Why don't we look at increasing and decreasing? So increasing and decreasing, we said we're going to draw basically our axis of symmetry, right? Draw a vertical line through where that graph changes direction at the vertex. What x number does that go through? 2. You have an arrow on the left. Where's that going? Negative infinity. And you have an arrow on the right. Where's that going? Positive. So remember, we're looking at the graph from the left to the right. So from the left to the right, what is this doing from negative infinity to 2? It's increasing. What is it doing from 2 to infinity? It's decreasing. Does that make sense? All right, good. So let's go fill it in. Remember, this one has to be parentheses, right? No brackets here. Okay. Now, what about my end behaviors? As x approaches negative infinity, okay, if I'm on the x-axis and I want to walk towards negative infinity, I'm going to the left, right? So what is my left arm of the graph doing, or the left arrow? It's going down. Down to what? Which y value? Where are the y values going if you go down? Yeah, negative infinity. Okay? As x approaches infinity. So as your x numbers are going to infinity, that means the right arrow, right? The right arrow is doing what? Is what? To infinity? Negative infinity, because it's going down, right? If it was going up, if you have an arrow going up, then it's going to infinity, okay? And to be honest with you, guys, think about a parabola, right? If it's a U shape, then the ends are doing the same thing each time, right? If it's a U, then they're both going up. If it's the other way, they're both going down. Are you ever going to have a parabola that's doing one thing and the other arm is doing the other thing? No, they're always going to be doing, they're going in the same direction. All right, so x-intercept, we said these are probably going to be decimals. Okay, since we're looking for the x, the y's are zeros, yes? So with standard form, you know, you have so many different ways to solve these x's. You guys just solve them in so many different ways, right? You can factor, you can complete the square, you can use the quadratic formula, whatever you want to do, okay? But you know what, just for the sake of time, I'm going to put it in the calculator. So I'm at my graph, right? I'm going to go to second trace, 0. Yeah? So now you have to find 2 zeros. So I'm going to start by finding this one on the left. Okay? So I'm at it right now, blinking Bob, right on the x-intercept. It says left bound, so that means hit the left arrow, I don't know, 3 or 4 times. Hit enter. Now, when it says right bound, you want to go back to your 0 and then hit the right arrow 3 or 4 times. Because that x-intercept, that's kind of like your starting point. So from there, you go to the left. You go back. And then you go to the right. Okay? Hit enter. When it says guess, hit enter again. And they give you the 0. Okay? Negative 0.83. Right? Just rounded 2 decimal places. Oh no. Negative 0.83. Okay? Let's find the other one. So I'm going to hit graph again, clear everything out. And then I'm going to go to second trace, 0. I'm going to move my blinking Bob over to the other one. There. As close as you can get to it. You know, it doesn't have to be right on it. It doesn't work. So you're on this x-intercept. Says go to the left. Okay. 1, 2, 3, 4. Hit enter. Now go back. And then it says go to the right. Because it says right bound. So right. 1, 2, 3, 4. Hit enter. Hit enter again. And you have 4.83, comma, what is this thing? Negative 1e, negative 12. What did I tell you that e is? Scientific notation. Remember when we did imaginary numbers, right? So if you ever get an e with these graphs, it is 0. Because it's negative 1 times 10 to the negative 12 power, 0. Okay? So what was this? Positive 4.83, comma 0. Okay? Questions? All right. Let's try another one. Huh? Using what? You think class is about to end? Somebody let him know what time class ends. Class is about to end. Okay. That was pretty good timing though. But no, that's not us. Sorry. Okay, go back to I don't know. What do you guys want to do? Do you want to do number 2 or do you want to try number 4? You guys choose. You want to try number 2? All right, let's try number 2. You guys try it. I don't care which method you use. You can use by hand, use the calculator, whatever. You want to use a mix? That's great. So for number 4, when you go to graph this vertex, I mean, you're just going to have to eyeball this one. Okay. What else can I fill in here? What else is always true? Okay, well, you can fill in the table, but, you know, even before I, like, go into the calculator and do all of that, what's your domain? Yeah, negative infinity to infinity. And, you know, so this has a minimum, right? That means my graph is a U shape, right? Yeah? So then think about your range. What does that mean about your range? It has to start at the y number of your vertex. Do you agree? Yeah? The y number of your vertex is negative 6.125. And then since it's a U shape, it's going up to where? Okay. So I realize I didn't graph it yet, but I can get the range. Okay. So when you guys go to graph number 4, this one looks a little weird. But the y-intercept is not weird. What's the y-intercept? 0, negative 5, right? If you're looking for the y-intercept, that means that your x is a 0, right? So for your increasing, decreasing, remember, you're drawing a line. Basically, you're drawing your axis of symmetry, right? So that's at 0.75. You have an arrow on the left, so that's negative infinity. Arrow on the right, so that's infinity, right? What is this graph doing from negative infinity to 0.75, from the left to the right? What's it doing from here to here? Decreasing. What's it doing from 0.75 to infinity? Increasing. So there you go. Those are your increasing and decreasing intervals.
Infinity 0.75. Oh, yeah.
Right? All right, and what are your end behaviors doing?
Infinity.
Infinity, because they're both going up. All right, so your x-intercepts. So your x-intercepts are not exact, right? They're like there and there. We have one that's exact, right? Negative 1, 0. That one's good. But we have another one. Okay?
5.
What is it?
Like 0.50.
Is it like point? No.
No, it's like
It's
0.75.
3.
All right, so then I can go back here. Is this it? No,
No.
this is not it. So I'm going to put it in my calculator, find the 0. So if I want to find that 0, I mean, it looks like about 2.5, right? Second trace 0. So I'm going to move my blinking bob towards it. Put it right, okay, there. You know what? This is probably the best. Right there, right? And then from here it says go left. Okay, left arrow, 1, 2, 3. Hit enter. And then go back. And now it says go to the right. So right arrow, 1, 2, 3. Hit enter. Hit enter again. Okay, 2.50. Is that what you said? Good. And then 2.5, comma 0. All right? Any questions?